This lesson is for Advanced Algebra, Lesson 6.2 on absolute value, square roots, and quadratics. First, I just have to say I'm sorry about the quality of my voice, but I don't want to miss out creating this video for those students who are absent. Know that I'm looking at or thinking about recreating the video again when my voice returns. First topic for the lesson is on absolute value. I'm hoping most students already know what absolute value is, so this is hopefully going to be a review. Absolute value measures a distance away from zero. I usually instruct students to imagine a number line, usually with zero in the middle, positive numbers to the right, negative numbers to the left. So if you're measuring something's distance away from zero, know that you could be going to the right or to the left, or possibly both. You will probably need to do absolute value on your graphing calculator, and I know that on the CAS calculators there is the absolute value command hidden in the math menus, so it'll probably be easier just to remember to type in ABS, which is the abbreviation for absolute value, and then just put whatever you're trying to find the absolute value of inside the parentheses. On a TI-81 you would just go to the math menu, choose I believe number, and again ABS will be one of your choices. I also just want to quickly mention that the absolute value graph, if you were to graph it, if you did absolute value of x, would be a V-shaped graph. So let's just quickly practice absolute value just in general. The bars here indicate that you need to find the absolute value of whatever's on the inside. So in this case, if we're finding the absolute value of 7, the distance away from 0 of the number 7 is still a 7. So then when you do the absolute value of a negative number, again you're measuring the distance away from 0, and that distance will be a positive number. So when we say positive, or when we say the absolute value of negative 7, we'll say positive 7 for the answer. So what that's useful for us is when we're solving with absolute value. So if you're trying to find a number that when you take the absolute value of it you get 7, obviously from what the previous questions that we just did, x could either be 7 or a negative 7, because when you take the absolute value after that you would get a positive. So it's super important for students to remember when you're solving, when you're doing absolute value, you'll always have two answers. Now keep in mind that they won't always necessarily be one positive and one negative, but you should end up with two answers because you can either be to the right or to the left and take the absolute value and get your results. So when you're trying to solve something like x plus 6, absolute value equals 7.2, we have to solve it twice because inside the bars there we could get a negative 7.2 or we could get a positive 7.2, because then when we take the absolute value of the answer it will turn into positive 7.2. So we always need to make sure that we get two answers when we do absolute value with solving. So in both cases we're going to take away 6 from both sides. In this case we'll get a negative 13.2 for one answer, and we'll get positive 1.2 for that answer. So in this case we get a positive and a negative. Note that that's again not always the case. We do get two answers, but they won't necessarily be one positive and one negative. So let's try one from the homework. This is number 7 in the assignment. So again we need to solve it twice, once for positive 5 and again with a negative 5, because whatever we get on the inside here could be a positive or a negative, because then you'll take the absolute value to get the positive. So just do regular solving skills here. We're going to take the opposite of the 7 to both sides. 2x drops down. Divide both sides by 2 here, and we know that we're going to get a negative 1. Over here, when we subtract the 7 and drop down the 2x, we end up with negative 12. So in this case, when we divide by the 2, now we get a negative 6. So notice that both answers in this case are negative. So don't always expect that you're going to get one positive answer and one negative answer. A lot of times kids will do the first answer and they'll just say, okay, then my answers are positive and negative 1. Don't do that. Okay, make sure you solve it 2 times with whatever it's equal to being one positive and one negative. The other thing that the lesson is about is solving using square roots. When you solve using a square root, you're going to get an absolute value answer as well, which again means you should have a positive and a negative. When we do this, we're also going to talk about simplifying radicals. So when you solve here, to undo a square, you would do the square root of both sides. Squaring and square roots cancel each other out. Now, most of the time you're just going to leave your answer like that, keeping in mind that you should have a positive and a negative in front of it. But there's something called perfect squares that you need to worry about. So let's talk about perfect square numbers for a second. Perfect squares are the results of doing 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so on. So the perfect square numbers are numbers like 4, 9, 16, 25, 36, and so on. These are all numbers that when you take the square root of them, you get a whole number back. So when you're working with a square root in particular, like we will if we're solving a quadratic, we want to try to simplify this radical. When you simplify the radical, you're trying to see if any of these perfect squares go into that number. One of the characteristics of square root numbers, of square roots themselves, is that they can be broken up into separate pieces. So let's just look at the number 12 here. 4 goes into that evenly, so I'm going to rewrite 12 as 4 times 3. And then one of the characteristics of a radical symbol, the square root symbol, is that you can break it up into two separate symbols. So square root of 4 times 3 is the same as square root of 4 times square root of 3. So it's almost like breaking up that symbol, and it performs the same operation. So then when you take the square root of 4, you get 2, and then the square root of the 3 has to stay. So there's our final answer. It's the same as saying the square root of 12, but it's a more simplified version. It's kind of the difference between getting an answer of 2/4 and then simplifying it down to 1/2. So it's that same idea. So let's just try that with one more practice question, keeping in mind that you'll still have to review or come back to these perfect square values. So let's solve x squared equals 40. So we would take the square root of both sides. We know that we're going to get positive and negative square root of 40. But we want to simplify that radical or that square root if we can. And so let's look at numbers from the list previously that go into 40. 4 and 10 work. If you put the number from the perfect square list first, that'll be better because then that number is going to come outside the radical sign eventually. So we're going to do square root of 4 or square root of 10 separately. Know that you don't have to show both of these steps, you can just show one or the other. And then when you do the square root of 4, you know that you get a 2 there. Keep in mind that when you're doing trying to find a number from the perfect square list, if 4 works, you should also consider seeing if 16 also works. I know that 16 doesn't go into 40, so I didn't, but that's a good practice to get into because you want to always pull out the largest perfect square that you can. So if 4 goes in evenly, you should see if 16 also does as well. Same thing with 9 and 36. 9 is a factor of 36. So if you're pulling out a 9 from your number, see if you can pull out 36 as well. Always try to grab the largest number that you can. So again, this is a more simplified version of what we had when we solved. Students will need to simplify the radical as much as possible. The last topic in the lesson is talking about rational and irrational numbers. They may ask you to classify your answer by name. Rational numbers the word rational comes from the word ratio, and a ratio is another word for a fraction. So when we're talking about rational numbers, they are numbers that can be written as fractions. So all regular numbers and their opposites can be written as fractions. Obviously, all fractions can be written as fractions. And then some square roots can also be written as fractions. Things like square root of 2, square root of 4, square root of 4, square root of 9. In the rational list, we would also include repeating decimals, so like 2/3, which is the same as 0.6 repeating. Those would also be considered rational numbers. By the way, back up here, one quick thing I want to mention, this answer that we got would be considered an exact answer. If they ask you for an approximate answer, then you would go ahead and type in 2 times square root of 10 and you'd get a rounded off decimal answer. So that approximate would mean you could give a decimal that's rounded. When you give an exact answer, you're giving a non-rounded decimal answer. Sorry about that. And then irrational numbers are infinitely non-repeating decimals, which means they can't be written as fractions. The typical ones that we use for irrational numbers are numbers like square root of 2, square root of 3. We wouldn't say square root of 4 here because square root of 4 is a 2, square root of 5, etc. Pi is another very famous irrational number. It's a infinite non-repeating decimal that goes on forever. So they may ask you to classify your answer as being rational or not. If you get a number like a number with a radical in it, like radical 10, you'd say that it was irrational.